begin by dissolving the copper sulfate into water, and we added ammonia. First it formed a cloudy precipitant that was blue, and then we developed it into a clear blue liquid. We then added more water until the meniscus reached 25 milliliters. We then added this as our stock solution into the beaker.
To make our first dilution, we used a Moore pipette to drop an amount of our solution and recorded the value the meniscus stopped at. We then transferred an amount of our solution to a 25 milliliter flask and recorded the final volume. We used the initial and final volumes to calculate the delivered volume. Afterwards, we filled the rest of the flask with water, then transferred out our first dilution to a beaker. We repeated these steps 2 more times, drawing from the previous dilution each time, to make a total of 3 dilutions.
The purpose of making the serial dilutions is to measure the different types of absorbance and identify the relationship between the concentration and absorption. Using the relationship of M1V1 equals M2V2, we calculated the concentrations of each dilution.
We have all our solutions. We transferred each of them into cuvettes. We wiped down the sides of the cuvettes and placed water into the spectrophotometer to create our zero value, and then placed our darkest solution to find the wavelength of light it absorbs best. Afterwards, we recorded the amount of absorbance of each of our dilutions. Using the data collected from the spectrophotometer, we created a calibration curve, which we used to determine the concentration of our dilute unknown solution, which in turn we used to calculate the original unknown's concentration.